excited to be here. Actually, it was really fun just listening to Rob talk. I've known him for quite a while, actually, since that first time that we were here at Rapid with America Makes. And it's just been kind of fun meeting some old friends and talking with people. As Debbie mentioned, this is probably going to be a bit of a mind stretch. So a pretty high-speed drive through where I see things going, and maybe a different kind of mindset that we might want to have about what's to come. I think maybe if there's anything you walk away with is that we haven't seen anything yet. And that's what I really want you to think about. So I'm going to be talking about the nature of things and what happens when the very nature of things and places and products and maybe the way we collaborate with tools changes in a fundamental way. You know, every time we make something, we learn about the world. You know, it's actually this kind of feedback loop. It's an infinite loop that goes between making and learning. And I think when we separate those things, when we talk about making and we don't talk about learning, I think we're doing ourselves a disservice. And so first I'm going to set a little background, and then I'll talk a little bit about some of the big trends and how they're intersecting with making and learning. And then I'll talk a little bit at the end about how we might prepare for what's to come. Every time we make something, we learn something about the world. Every time we learn something, we actually explore a new space of the universe, and we learn what won't work and what will work. And sometimes we fall on our face learning that. But the future of making things is radically changing. And so is the future of learning things. And it's not only learning things, us learning things, it's actually things that learn. And that's something else that's, I think, a challenge to us in the way we think. We're not alone anymore. There are things out there that learn what happens when our products actually participate in their own redesign. You know, at that point of inflection, the point of highest leverage is research and development. We're going to hear a lot about that over the next few days. We're going to learn about some exciting new things happening in additive manufacturing. But that's the point of inflection. Can we make that a bigger curve? Can we swing out and learn more things about the future of making things? Can we do more? And can we learn more about the universe? And can we take advantage of that? That's the question. And R&D is interesting, too, because not only is there R&D happening in making things, but there's also R&D happening in learning things. I'll share one example of that. I'm not sure how many people heard about AlphaGo. It was a competition to actually beat the best Go player in the world. Anybody? Looks like a few people. What's kind of interesting about this is that a long time ago it was chess. You know, maybe computers someday will beat us at chess. You know, then it was Jeopardy. Maybe we could beat Alex Trebek. I don't know. But most recently, this was Go. And Go is an interesting game. If you don't know about it, it's a strategy game. Uses little sort of black and white pebbles. And it has more moves than atoms in the universe. So it's a pretty complex strategy game. It's really much bigger. Chess is a closed game. Go is an open game. The curious story, though, about this isn't about that AlphaGo beat a human and the best human in the world. The curious story, and this is an article that actually outlines it, is about the process. What they did was they actually had a machine, this deep learning thing called AlphaGo, played against younger versions of itself in something called reinforcement learning. It's actually how you learn how to play tennis, how you learn how to do different things. You know, Venus playing against Serena, pushing up the mastery curve by kind of playing. So AlphaGo played against a younger version of itself. Sort of version 2 played against version 1.5. But the other thing it did is it played against the 1,000th best player in the world, human player. And then it played against the 900th. And then it plays against the 800th. And then it played against the 700th. So it was pulling itself out towards the mastery curve. What's curious is what happened with number 633. It was this person who had spent decades actually learning how to play Go. It was his passion. And 633 kept drawing a line in the sand and going, you're not going to cross this. Humans are still going to keep winning Go. And he kept succeeding. And at the time, we thought maybe that was as far as computers would go. They would be able to do like 633. We broke 1,000. That's pretty good. One day he lost. He figured it was a bad day. No problem. He came back. He actually won the next day. It was just a bad day. And then he lost, and he never won again. So number 633 had his passion challenged. This wasn't his job. This was his life. And he went home after that, and he started having nightmares. He started thinking about what would happen. What happened to my career? What happened to my life when suddenly this thing that I did is lost to me? Now, a curious thing happened, though, after a few weeks. He started actually having dreams and started thinking about all the moves that the machine did that no human had ever done in the history of the world. Because the entire sort of event horizon of all humans playing Go was over here, and the machine was doing weird things over here. And he was the only person who saw them. And he actually called up Google and he said, can I join the team? I'm just going to be on the other side of the mastery curve. I'll be like, the younger player playing against the machine instead of the master. And they invited him back in, and he started playing. And by the time AlphaGo beat the #1 player in the world, number 633 was in the 300s. So he had actually doubled his experiences and doubled his skills better than anybody on the planet in the fastest time ever seen. In 4 months, he went from 633 to 300. And that's the story we don't really hear too much about, which is the capacity for learning to actually influence the way we learn as well. So that's precursor, and I'll get back to that in a little while. I'll give you a little background. So I work at a place called Maya. It was started about 28 years ago out of Carnegie Mellon, right down the hall, right down the streets. And our focus was something that Raymond Loewy, an industrial designer in the 1930s, who tried to help design our way out of the Depression, said, we want to focus on the most advanced yet acceptable space, the Maya zone. And we want to focus on taming complexity, taking that incredible, powerful stuff, and bringing it to people so that we can actually have superpowers. And I'm the chairman of that group, and I ran it for a number of years. And our focus was really 2 antidotes to the challenge coming and then the real challenge. The 2 antidotes were, if we can make anything, and we can make it right. And I think over the next 2 or 3 days, we're going to see about all sorts of new ways we can make things. That's table stakes. The question is, what's the right thing to make? And that means you have to put people first. And so we focus a lot on human-centered design. How do we put people first and decide what we should make, not just if we should make it? Should we make it? The other thing we focused on was architectural stuff. How do you not see just the tip of the iceberg, but actually see the entire iceberg so that you can see the pattern, the underlying theory, the architectural process behind what's happening, so that while everyone else is scrambling, you can actually understand what's going to come in terms of theory. And lastly, we thought the biggest challenge in the world, and we still do, is the connected world. The fact that there is no such thing as a disconnected product, service, factory, experience. It's over. The connected world. And we wrote a book about this that actually pulled together 20-some years worth of research, and it was called Trillions. And it was about what happens if we lived in a sea of information devices. If there were trillions of things, not 8 billion supercomputers in your pocket that we have today with cell phones, but trillions. That's a fundamentally different kind of math, and it's going to be here in probably 5 years. To give you a sense, in 2010, the world made more microprocessors than grains of sand and made them cheaper. So this is a really important thing. We actually made 10 billion microprocessors in 1 year alone in 2010. So the world's saturated with computation. We wrote a book about it. We thought of it as a sea of information devices. And we kind of cataloged the process by talking about it as sort of chapter headings along a journey. And there are plenty of steps along the way. If you're interested, find Trillions. But the really important thing was, it's not about fighting this current mountain, climbing up this current mountain of complexity, billions of cell phones, the client-server model, the web, all this stuff that was invented in the 1950s or 1960s that we're celebrating today. It's actually about climbing to the top of that mountain and stop fighting over the last few inches. MySpace dies for Facebook to win, and we're fighting over this kind of first iteration of the information age. It's really, when you get to that mountain, you realize there's a much bigger mountain off in the distance. And that's trillions of things, not billions of things. And anything multiplied by a trillion turns out to be a really fun number. And so there are huge opportunities. In fact, McKinsey put out a report last year that said between $3 and $11 trillion will be added to the GDP globally every year by 2025, just from the Internet of Things part of trillions. That's just the stuff connected to the Internet. So there's a huge opportunity there. Debbie mentioned I'm also a fellow at a place called Autodesk. I split my time between Maya and Autodesk as I'm kind of writing a new book. And what happened was I thought trillions, the Internet of Things, a sea of information devices, that was going to be plenty for the rest of my career. But as I got out into the world, and I met people like Rob and others at America Makes, I realized that actually the way we design and manufacture things is fundamentally changing. It's not just this one big megatrend, everything getting connected. It's actually intersecting with some other megatrends as well. And I started doing some experiments at Autodesk. And as a research fellow, I started thinking about what happens when you combine the Internet of Things with digital manufacturing, that sort of lowering barrier, liquidity between bits and atoms. And all those things have opinions because they have machine learning and they've got sensors that they can go ahead and do their own A/B tests. So what happens when all three of those megatrends come together? And I call it a sort of primordial soup because in the natural way, as the Earth evolved, we reached this point where a spark of light hit the primordial soup and something new burst out onto the surface of the Earth, and we call it life. And so I think there's a primordial soup moment. And I want to give you a sense of what's inside of this sort of primordial soup, and then we'll talk about maybe how we prepare. When I say the Internet of Things, I think a lot of people think of like the Nest thermostat or Nest fire alarm. And it's interesting to ask the question, why did Google buy Nest? Google makes lots of money just from information. They don't have to like drill for oil, make something physical, keep it in a warehouse. Why would they go at the economics suck in manufacturing the physical world? It's really tricky. You guys all know that. So why did they buy Google? Why did they buy Nest? And the interesting question, I think when you think about it, is because they wanted to actually own oil wells that were installed in your living room, between your living room and your kitchen. And they wanted to harvest all the data pouring off like industrial waste, pouring off those walls. Like, what temperature is it, really? And what's the humidity? Because humidity changes your feeling of temperature. And who's moving around in the kitchen right now? Is Bobby checking the fridge at 2 a.m.? What's going on? So if your wall could talk, it would probably tell you amazing things. And in the natural world, we have something called the information carbon cycle. Nothing gets wasted. All that exhaust is actually food for somebody else. And so they really wanted to say, I want to harvest all that information. When you sell the house, it's probably going to go up to the next house as well. The Nest will stay there, and they'll end up harvesting maybe 15 years of someone's 2 or 3 families' lives. So that's the first thing. That's what we think of when we say the Internet of Things. There's another spin out of Carnegie Mellon named Body Media that we worked with quite a bit. And they said, what if we could harvest the media pouring off your body? What if we could find the owner's manual by basically harvesting all that data pouring off your body? Could we somehow actually find a way to lose weight, to actually be healthier, and things like that? And curiously enough, and I want you to remember this, they took tens of thousands of pounds of equipment from rehabilitation clinics. That was worth tens of or hundreds of thousands of dollars. And they tested a whole bunch of people with the best sensors and the best tools imaginable. And then they boiled those down with some algorithms to $50 worth of sensors. Six sensors, $50, and they replaced all the rest with algorithms. And they basically replaced mass with math. And I think we're going to see this in every industry, and we're going to see this in every product that you make, and every factory you own, and every service you offer. Replacing mass with math. And so they got to the point, with a few 100,000 people, they captured over 500 trillion data points. And they started seeing, they actually got FDA approval as the very first wearable that helped people lose weight with clinical proof. They were starting to find the owner's manual for the human body. So that's what I think about when I think about the Internet of Things, is actually how do we harvest all this exhaust data? Just like in nature, nothing gets wasted. I did a little project that was kind of fun. It was like a sketch of the future. I hired a bunch of interns while I was at Autodesk, and we decided to say, what would happen if we could use some other Internet of Things sensors? They call them reality computing sensors. You guys have probably heard of them. And actually ripped all the sort of history of automotive design. And so this was a little project that we called HackRod. And the idea was, what if 3 kids in a garage could start their own car company? And the first thing we did was we said, let's grab a bunch of those sensors. Let's actually sense the physical world and rip the existing best vehicles that are made to jump football fields and to do various things, made by the wizards of Chrome Mali that design these things. And we started ripping them, and we started pulling them into digital software. So we said, instead of spending most of our time just getting the thing in software so that we could finally do what if we could rip it casually? What if we could rip it every day? And what if we could put sensors to capture the other kind of reality, like organic compound flowing over the car as it's moving through the space, like the actual stresses and strains on the driver and the stresses and strains on the metals as they were being driven. And so we explored this. This was with a bunch of interns. We were playing a little game that I'll explain later called entry-level and exit-level interns. I was the exit-level intern. And a bunch of interns were actually in charge of this project. And over the first afternoon out in the Mojave, we captured 4 billion data points. So I would say a lot of car companies don't capture that in a year. We captured that in the first day, and these were about 23-year-old kids. So they were starting to explore what would happen when suddenly capturing information from the actual device mattered, and you could do it easily. And they also looked at capturing the grip on the wheel, because obviously the driver is a part of the experience of driving a car too, and even the EEG, because now you can have cloud-based EEG tracking. And they started seeing things like planning and valence to task. Was he enjoying the task? Was he planning? Was he anticipating it? And how were those things coordinating with the actual stresses and strains on the vehicle? Was he predicting things that were going to happen on the vehicle before we could predict it with other kinds of sensors? And so this was a really interesting experiment in saying, what would happen if a car began to participate in its own redesign? Now, when I talk about digital manufacturing, which is another one of these sort of pieces of the primordial soup. You're going to hear a lot about ways that we can actually lower weight, increase surface area, do all sorts of amazing things with additive manufacturing. So I'm not going to belabor that. I think there are a lot of speakers that are going to talk about that stuff. It's an amazing place where we can suddenly start shifting models and envisioning entirely new economics. One of my researchers that I'm working with, Maximiliano, is working on something around actually creating hybrid composites. So your skin is a hybrid composite. It's got sensors, it's got blood flow, it actually dissipates heat, it's got muscles, if you could dig a little deeper. What would happen if we could do that with graphene, which is maybe something like 200 times stronger than metal, and do it free form and embed different kinds of behaviors in it so that we get functional gradients as we're doing it. And this is just an early experiment in saying what happens with digital manufacturing if we could basically print in the fiber optics, print in the conductors, print in the insulators, and turn the entire system into something that senses and do it in a free form fashion. Out of one material, but basically programmably change that material over time. So now we end up with metamaterials. So early days, this is just super early research, but it gives you a hint at what's happening in digital manufacturing. The other thing that's happening in digital manufacturing is taking those machine learning algorithms and saying, could we do generative design with them? And so in this case, we're working on a project called Dreamcatcher, which basically says, could you not draw any circles or shapes or bevels anymore in your mechanical engineering things? Could the computer do the busy work? Could you just focus on the goals and the constraints and the forces? So we actually took all those forces coming off all those parts of the hack rod, and we said, what if form follows forces? What if we could take those forces and use them as inputs and have the system play with us a little bit and generate, almost like a teammate that could just draw really quickly? And we experimented with that. And the generative design idea was that we basically set a few set points and a few goals, and then the system plays with us, sort of like a jazz improvisation, where we do a little bit and they come back and riff on that, and we push a little bit more and they riff on it as well. So we set the goals and the constraints, and then the system began evolving a different chassis made out of titanium, a different chassis made out of aluminum, a different chassis actually made of the old-fashioned chrome moly, but just with different ways. All we did was draw the arrows for the forces and the constraints. So this is a sort of exploration of what would happen if one person had the power of 10,000 engineers using machine learning. And we were able to look at all the trade-offs that we're ultimately making and explore what happens when form follows forces. This last one is a chassis that's actually made of the same chrome moly. So not even doing additive manufacturing, just forcing you to think about just changing the design constraints and allowing normal manufacturers, people who have built amazing vehicles in the past, to play with it. And then outputting it in a generative way as well, so that it actually says, wow, how would I assemble this thing? Because you probably can't come up with assembly instructions when you've got all sorts of complex things. Why not have the system actually think about the assembly itself? And so in this case, the structural design was really complex. We evolved it for chrome moly, and what it did was basically came up with ways that it could be assembled out of chrome moly, multi thicknesses of the metal, automatically set the cut points, automatically do the bending, automatically fabricate the parts, laser etch the labels on it so that we actually knew how to assemble it, kind of like a kit of parts. And think about how we could flat pack this and ship it back down to LA to the guys who were fabricating this stuff and have them build up a brand new chassis in a week. Now this is the idea of saying, let's not only think of additive, but let's think about the whole spectrum of how digital manufacturing works and explore that process. And what was really curious about this was the wizards of chrome moly designed this thing after they've won 10 Pikes Peak challenges and Baja 1000 challenges. They said there's no way you could save a lot more weight. We got 20% off the weight savings. And they fell in love with the process. Because now they started thinking about just doing little bits of generative design, scanning, ripping, exploring, and getting into this new space without having to bite off the entire thing. This was the most recent vehicle. This was produced back in December. And now what we're working on is actually censoring it back up and going back out into the field. And this is the dream that the 3 kids that in the garage are thinking about. And it really implies a big change in the entire supply chain. Right? What parts should be made of carbon fiber? What parts should be harvested from a local recycler within 5 miles? What parts should be printed? So how do we think about that in a generative way as well? How do we take additively manufactured parts and actually casually assemble them with off-the-shelf components so that we're thinking of these as hybrids, the same way most of nature works? It's not all one thing. It's all sorts of different things that come together. So how do we think of manufacturability of large-scale products? Now, I'm just finishing up the digital manufacturing part, and then I'm going to go to the last kind of big trend, But I wanted to flag, Chuck Hall, amazing innovation, this idea of photopolymers and printing, $250,000 or more. Then we get Formlabs, $8,000. What happens when that kind of technology comes down to 2 billion people have half of a 3D printer like that in their pocket, and the other half costs $99? So the consumerization of this technology changes things as well. Here's a team out of Italy, Ono, Pietro and team, who said, what if we could just plop this down on top of your phone and people could email you a gift or text message you a gift, and about 3 hours later you end up with a gift. And if you had an iPad Pro, you could set multiple build platforms on top of it. You could have rubber parts and clear parts and mechanical parts and performing parts. And they're working with whole new sets of polymers that are based on chitosan, which are shrimp shells, and other kinds of things that are not toxic, which is kind of important if we're going to suddenly allow 2 billion people to be able to do it. So this is a time lapse of about 3 hours. They did a Kickstarter, asked for $200,000, got $2 million in 30 days. And they're actually going to be, I already held one of them in my hand, and they're shipping. They're in a full production line run probably in the next month or two. So things are changing, and that might look like a toy to you. And when we talk about toys, it's interesting to think about it. Here's Barbie. I think of this as Barbie Economics. Barbie's about a $2 billion industry. And if you think of it, you can fit maybe 13,000 Barbie dolls into a shipping container. But if you just shift the photopolymer and you manufacture locally, you could fit the equivalent of 250,000 in a shipping container. So will we really ship things all over the world, or will we really just do a hell of a lot more stuff locally, the same way most ecosystems do? And will we only ship the rarest of things? Now this economics, it's tricky because we're not quite there yet, and this industry is trying to explore this, but I think it's coming. So I'm going to end with machine learning and talk a little bit about how we can prepare. I'm not sure how many people feel really comfortable when I say machine learning, what you think about. I think a lot of people think of sort of the Ray Kurzweil axis. It's the singularity. At some point, we will probably have a chip embedded in our brain, and then at some point, we will become the Borg, and there'll be a singularity moment, and we will become them. I think that's Ray Kurzweil and the singularity kind of science fiction axis. That might be what happens. We become them, and we are subsumed in the Borg. Or some of us think about maybe the Muscovites, like Elon Musk and Stephen Hawking, who basically say you better pray, because ultimately we're going to become prey. And their whole attitude and their whole approach is basically saying, first you're going to hope that you become a pet, and you're going to pray that you're a cat, because cats have a pretty nice life. And then you'll be hunted. And then there'll be an extinction event, and really humans were just a bootloader for the next intelligence. That's that axis. Yay, team. Okay, hear that a lot from Silicon Valley. Okay, so here's the thing. I'm really interested in all of the research that we're doing around primordial and this research in this space at Autodesk, at Maya, and other places where we're really exploring is around a third axis. And that third axis I call play. So think about Wynton Marsalis, who's playing a jazz instrument every night. He's meeting somebody new. He's riffing. He's got his own solo, but he gets to play and explore. His brain is growing every day. I hung out with a good friend of mine, is a 90-year-old jazz musician, still plays every night in Manhattan. He remembers Franklin Delano Roosevelt coming to town, to give you a sense of scale here. And his brain is unbelievable. Every night is different. Every place is different. What if we think of, Tina Fey? What if we think of Wynton Marsalis? What if we think of improvisation? And think about the possibilities of raising lots and lots and lots of teammates and playmates and different people who can explore, or different things that can explore, and think about differently if we could riff and play with all the products that we ship out into the world. And they're all experimenting in different ways. In that axis, maybe it starts with these things are pets, more like a dog. If you look at Alexa and you say, Alexa, it actually swivels its head like a dog and looks at you. And if your wife or somebody else says, Alexa, it swivels its head. That was a design decision on purpose. Fixed vocabulary, I can do a few things just like a dog. I'm going to give up and look at you when it's anything more than like defending the perimeter. Really powerful, really limited, ultimately maybe to getting to jazz. So I want to show you what happens when you think differently about that. Qualcomm came up with a chip. It's like a $10 chip. No writing any code. There's no reason to have a software engineer. That's like a really weird blue-collar job from the 2000s. What you do is you raise the product like a child. You give it a carrot when it goes over the thing you want, and you train it. If you've had a dog, you learn how to train. And what happens, which is kind of interesting, is you end up growing. You learn a lot more about leadership when you have a dog, and you end up growing a lot, and they grow as well. All decision making done with biologically realistic neural networks on a $5, $10 chip, not even connected to the internet. we started thinking about how that might play out with design tools. This is more the Dreamcatcher. What if I just set those things and I start playing like a jazz musician with it? And what if I did that with even physical spaces? In this case, architects worked with our new facility in Toronto and came up with hundreds of thousands of permutations based on lighting and sensors and flow and how people work together, and then evolved a bunch that the architects could play with. And then here's an example that I think is kind of interesting in play and machine learning. We've developed something called Design Graph, and it's actually available now. It's an interesting thing. We think of it as autocomplete for the physical world. So Facebook has a graph of all your friends, the social graph. LinkedIn has a graph of your careers. I don't know what Google has, a graph of a lot of things in your life, but at least you or I's. What if we could sort of consume all the physical things in the world and actually chew on them and actually learn the language of physical things? And so we did unstructured, unsupervised training of an AI to learn thingness. In this case, I'll show you a teenager. This teenager happens to know a lot about cars. And it turns out if you click on a car, it figured out that cars are actually mostly made of axles. A lot of things pivot on other things in cars. And then it figured out the parts groups. It automatically figured out how gaskets go together. It said these gears often go with those gears. It figured out the social graph of things. These bolts go with those things. So what happens if you raised a child that way with your team, with your product, with your service, with your factory? What if you had somebody that was just learning along with you? And then I want to show this, and hopefully we can get audio. So watch this, and then it's a game that some kids and friends of mine were playing.
Hey, church. Looks like
I see bench, or stairs, or hexagon, or pillow, or pickup truck. I see police car, or car. I see ambulance, or shoe.
Come on.
I see bulldozer.
It's not a church. That's a mission. Perfect.
Sorry, I couldn't guess it.
Oh, tiger. Oh, a tiger. That's.
I see necklace, or garden hose, or bread, or beard. I see pool, or face, or potato. I see alarm clock, or calendar, or toothpaste, or cat.
Stripes.
I see cooler, or raccoon, or bee, or marker. Oh, I know, it's tiger.
Oh, that's really good. A postcard.
I see elbow, or foot, or pillow, or suitcase, or pool. I see diving board, or shoe, or bread, or calculator. I see map. I see hot dog,
That's my
or
postcard.
passport, or pizza.
Come on.
You
got passport. Why can't you get postcard?
I see steak, or toothpaste, or marker. Sorry, I couldn't guess it.
A helmet. Okay.
I see rainbow, or squiggle, or bread, or cookie. Oh, I know, it's helmet.
Stereo. What's a stereo?
It's like a radio, but it's in the car.
I see bench, or diving board, or pillow, or suitcase. I see radio, or television.
Oh, that looks
I'm
more like
not
a
sure
TV.
what that is. I see oven.
That looks more like a TV.
That looks like
Maybe if I add one there.
I see washing
Put
machine,
another one
or
there.
blender, or sink. Sorry, I couldn't guess it.
Square's pretty easy.
I see bench, or nail. Oh, I know, it's square.
Okay.
Guess 3 out of 6.
Show me the ones that it missed.
The ones that it missed were church. I think that's a pretty good church.
Whoa, that's a good one.
Yeah, that one's really good.
Can I try drawing one more?
And a postcard that it missed a postcard. Those look just like mine.
Somebody put an envelope with their postcard. Postcards don't have envelopes.
Yeah.
Yeah, people.
And then a stereo it also missed. Okay.
Oh, a stereo.
It's like a boombox thing.
Boombox thing.
So they just learned what a stereo was. It's like a boombox. So I wanted to show that because that was play. They were having fun. It was a competition. They were actually raising a slightly dumb machine learning algorithm. They were learning from it as well because the mentor effect is so powerful. When we actually externalize our learning and we teach it to others, we get a lot more out of it. And so they were actually learning by teaching. And in fact, they ended up learning a few things. You know, they learned about a better way to draw a church. You notice the younger girl said, oh, that's a good one. Now that she's primed, she's paying attention to those things. And she's able to generalize those. And then they learned about a stereo. So this is an interesting experiment. This was done by some Google researchers. And it hints at, I think, the way we can look at the world. So I've been working with a young artist. And I'll get back to the punchline here in a second. And I've been playing with this artist. They like to make things out of woodcuts. Can anybody tell what that is? It's like a cat. Yeah, so I gave the artist a picture of my cat. It turns out that artist is a machine learning agent developed by a Russian machine learning scientist who's interested in creativity and fascination. And he's actually set an economic set of barriers to make it really hard to throw things out unless you really hate them, or really easy to keep them or pay for them, or maybe hard to pay for them if you love them, so we can determine human fascination. And what's happening is it's named after a Russian word, ostranene, which means taking the familiar and making it strange, which is the way we think maybe art might make us excited. And I gave him a cat, and it took a woodcut, and it figured it out. A person's face, and it came up with something new that's really interesting and fascinating, a different kind of a way to carve something, maybe out of things. So think of that for a second, where you're giving it, one teammate knows one thing, one teammate knows another, and you jazz riff on it, and you come up with something new. Here's an interesting experiment we did with another intern, where we basically gave Design Graph, that teenager that knows how things work, we gave it to a robot arm, and we gave it basically a CAD file of a finally assembled set of Lego constructions. And we just kept putting these Lego constructions in. And it turns out a normal human child takes about 7 years to learn how to grasp things really well. So the first 7 years of your life, you're learning how to pick things up and really hold them. And so we basically gave it the summer, because machines can go pretty quick. And over the time of the summer, it figured out how to pick things up, it figured out how to orient things, it figured out how to assemble them, and it figured out how to assemble the entire assembly. And it figured out how many nubs there were. So this was basically machine learning for assembly and manufacturing. Completely unsupervised, just raised it like a child, just played with it. So now think about this for a second. You raise, if we look on the left, you raise a Design Graph child with the product you're working on. And it's a new teammate, just like a new intern. And then you raise maybe another child on how you manufacture things in an emerging country. And it learns all the code, it learns all the restrictions, it learns all the assemblability, it learns all what that machine and that factory can actually do. And you mash them up, and it generates maybe 80% of the new thing, and then you get to play with the fun results afterwards. So I'm going to end here and say, ultimately, when we look at digital manufacturing and machine learning and trillions, the Internet of Things, these are all not independent. These are all intersecting with each other. There are incredible new places for value, and it's probably going to be a lot more co-creation. It's going to be co-creation with your partners, with your customers. It's probably going to be co-creation with your machines and your products and your factories as well. So think of it as a little bit of jazz. Thank you.
Thanks, Mickey. That's fascinating. Just really, really cool stuff.
I'm crazy excited right now. A little dangerous.
Note, you can text your questions. We've got time for a few questions. Don't get left out. Great opportunity here. I'm going to start with the first question that I have here, which might strike fear in the hearts of this audience, so we'll see. Can augmented reality replace 3D printing in making anatomical models for medical professionals and students?
Ooh, interesting. So we didn't even talk about augmented reality, but I think this is an interesting space. We're doing quite a lot of work in this, in both augmented and virtual, although I think augmented is going to be the bigger game changer. Virtual is like an interstitial technology. But I would say this, the boundaries between the physical and the digital world are getting liquid in that space as well. So it's certainly first in collaboration. In that HackRod project, we actually had teammates in Venice, California, teammates in San Francisco, teammates and other people all using VR for an hour and a half or two, climbing on the ground, marking up the car, and things like that. It was a very strange thing to not spend just 15 minutes and then feel like throwing up. So I think there's something there. What's really interesting is that augmented reality and virtual reality can cause post-traumatic stress syndrome and can actually help cure some post-traumatic stress syndrome. So this is a very powerful technology. So I want to just flag that. I don't think we're really having a good conversation about that right now, but it's a very complex and deep technology because it is embodied learning. It is your body doing things. And so I think there's a huge opportunity there. Will it replace physical printout products for actually testing surgical things? I don't think it'll replace that in the short run, but I think maybe as we get better with haptics, better with pushbacks and things like that, that actually give us a sense of it, might come pretty close. I think it's more going to be about these trade-offs. Machine learning, when I talked about that, the real trade-off there is it takes something that's really rare, prediction, and it makes it dirt cheap. And all the services out there that count on prediction, think of like the big 6 consulting firms that throw 50,000 people at something to predict what you should do with your business, that might collapse. because things that prediction, valued really highly might collapse. But all the things that we could never do before, or the things that are enabled by prediction, suddenly explode. Self-driving cars. We couldn't do those unless we had really good prediction capabilities. So the same thing is true with AR and VR. I think it's going to actually be a fundamentally phase change thing. It's kind of clunky right now, and it's a little scary. But it is playing with embodied learning. And embodied learning is a really powerful thing. I've heard people say, oh, it'll never do this or it'll never do that. I wouldn't say never. I think somebody said if an elderly scientist says something is not possible, he's probably wrong. And if says it is possible, he's probably right. We don't know yet. We just don't know. It's a big universe.
That's right. That's awesome. We have some really cool questions coming in here, so I'm going to try to get to as many as I can. Here's one from Matthew at MIT, who gave me his name, so I'll call him out. When will Dreamcatcher be available for us to play with? I'm ready to riff, he said.
Yeah, so that's research, and it's important to flag, like a lot of the stuff I played with there was research. But what is interesting is some of this generative technology is actually coming out in the next few months in something called NetFab. So the very first versions of the Dreamcatcher stuff are going to be rolled out in NetFab, which is the big additive manufacturing sort of tool out of Autodesk. Some other little teeny bits of it are actually hidden inside of simulation tools inside of Fusion. So there are little bits that are actually there now. Students are playing with little parts of it. NetFab's going to have some, but the real power of that is still years to come. I mean, we're playing with different aspects of it. But the real excitement there is how do I encode my design intent in the tool? So as a new manufacturing technology comes out, it can relitigate it for me and generate lots of permutations instead of, I've got a spreadsheet that actually has all my bullet listed things I care about, but could I get in the design tool so I can play with it?
Mm-hmm. That's awesome. There's a couple questions here that kind of seem to center around the future, young people, skills development. How will that be different for our next generation of young people because they've grown, they're the digital natives, right? And maybe some of our digital natives aren't that young anymore. But how is that going to change? What are we going to see?
I love this question because it is fundamentally the focus of my research right now. So I'm thinking about what happens when we apply generative design to learning itself. Hey, can you put up my slides again real quick? Is that possible? Perfect. So I'm just going to, let's see if I can click. I don't seem to be able to click forward anymore. Can you guys just click forward a few slides? There we go. Okay. Ignore what I'm doing, but how do we prepare? So this is this idea of how do we prepare the next generation? Mm-hmm. And when I was growing up, I went K through 12. I went through this sort of supply chain called the industrialized education system. And ultimately, I was pumped out at the other end, maybe with a degree or a certificate, and then I was hoping I'd have one career my whole life. And that sounds great, right? And it was made because the Industrial Revolution needed a lot of people to work in factories and offices and things like that. But it was this very artificial construction. You did coursework to get majors. Majors were entirely artificial. You got credits. Credits were invented like Carnegie credits maybe 100 years ago. And it was a very if-this-then thing because we had to create kind of people who could fill a task. Ernst & Young recently said that university degrees almost show no correlation with success in careers, and they've actually striked off universities as a degree as a necessary thing for their hiring practices. Now, I'm not saying go that far. I actually think there's a lot of unmodeled stuff inside of universities. But this is what my life looked like. So, it's more like a wandering, meandering. I stumbled a lot. I worked at that place. It taught me some new skills. I worked at that place. I learned a new tool. It was really this meandering walk. And I didn't have a way to predict the future. But what if I could use prediction? Remember, we just said it comes down cheap. What if I could do Dreamcatcher for future me? And what if I could actually see emerging careers before they're out there? So could we apply generative design to learning itself? And we did a little teeny experiment, and you'll just see the little first part, and then we'll stop here, and you can come and find me, or come on over to the, I think Autodesk has a booth, and we can show you some stuff. But this was a little cloud-based product, and we said, what if I had a machine learning tool that was actually paying attention and playing with the designer? So here's a student who's building a pair of headphones, and the system is paying attention to it. Think of it as dynamic micro-credentialing using machine learning APIs. So it's doing this stuff, and it automatically discovers you just learned a new skill. And because it's able to look at all the skill trees in the world, it figured out where your skill fits. And it's able to kind of understand it. So it shows you the new skill that you learned. And so as you're kind of going through this process, you're learning new skills, you're finding out things. Maybe if you're a designer, I want to get into computer animation. It starts to show you the emerging skills for a computer animator or an industrial designer that haven't even been turned into a career yet. It starts riffing on future you and running out and seeing if you could do it. and ultimately finding you jobs out there. You know, so this opportunity to do that, and it plays on that mentor effect, and this is, again, just an experiment, but it gives you a sense of what happens when the product actually starts learning you, and gives you this chance. So I think kids are probably, I mean, those kids I just showed you are your future workforce. And they're raising AI children and playmates right now. So this isn't like way in the future. This is already happening.
That's awesome. A couple questions here about job creation, prosperity, what's the economic impact, how's that all going to come down? I mean, you know, there are people who think that automation takes jobs away. You know, how do we kind of approach that? What are your thoughts?
I don't know. That's a good question, guys. So I think I started this conversation by saying you haven't seen anything yet. I think every time we try to predict the demise of something, we're done inventing, we're wrong. So think of, I don't know how many people watch Jimmy Fallon or have been to a jazz performance, but every night somebody shows up and the Roots riff and make something new, every night. And it's new and it's exploration. And if you watch actually the series called Jazz, it was the Ken Burns documentary. When Marcellus talks and he says, look, I would show up, I don't know the other people, and they say, hey, let's start with Charlie Bird. He already knows the greats. And he starts playing, and this person starts taking him off in some weird direction. And his brain has to react and grow right there. And so there's no end point of jazz. There's no end point of those things. I think I want robots to decide when to build a bridge for a town. I don't think managing a city is fun. I'd like all of our students and our young people and things like that to actually dream bigger dreams. We have only got this teeny slice of the entire universe that we've explored. It is a big place out there. I wanted to have them dreaming about going to Alpha Centauri. I want to have them dreaming, let's get this basic stuff out of the way. So will there be casualties? Will there be challenges? I think the interstitial space is going to be the hardest place. Right? I'm pretty sure over-the-road truckers, which is a great middle-class career and has helped put a lot of people through college, I'm pretty sure they're going to have a hard time when self-driving cars come along. But I suspect we have to focus more not on retraining, but on actually having a different set of mindsets and tool sets and skill sets and looking for interstitial ways. I think of it as Mr. Miyagi. Anybody see Karate Kid?
Of course.
Of course, you saw. Okay, Mr. Miyagi had that kid washing the car all the time. And the kid's like, damn it, why are you making me wash the car? But what he was really doing was he was learning muscle memory for the next job. And with prediction, we can start to do that. We can actually, in this current job, start teaching you muscle memory for the next job that will be coming. And that's pretty exciting. I mean, I'd like to start a new research project. If anybody's interested, I'm going to call it Mr. Miyagi.
Wax on, wax off.
Wax
right?
on, wax off.
That's awesome. Here's a couple other questions more on the Barbie Economics, which I was very good at Barbie Economics, so that's awesome. You know, it's saying that economies of scale typically in a business are ways to achieve success. So how do some of these technologies, including 3D printing, maybe change that model?
Yeah, I don't know. I think there's got to be a lot of experimentation. I would say one of the best things you can do right now, if you're in this audience and you're trying to figure out where the economics are in this, I would hire a few machine learning interns. I'd hire a few design interns. I would mash them up together with maybe some electrical engineers and some other people, and I'd start doing some little pilots. Try to explore a year and a week, a decade and a month. Try to start experimenting in this space, because it's non-deterministic. I don't think anyone quite knows. I did a project at Maya that if you ever get a chance to come visit our labs, you should definitely check out. We basically took machine learning, digital manufacturing, 3D printing, and sensors. It was my first primordial experiment. And we ended up able to come up with 2 micro factories for Oreo. It was very tasty. I think I was paid in chocolate chip cookies. Yeah, and basically, we were able to manufacture one of 10,000 flavors of Oreo every 2 minutes. Food safe, based on what was trending on Twitter. It was a very silly thing. But what was curious is they ended up getting to the point where they were saying, if I could put these in college campuses, I could actually detect the next wave. And if you worked out really hard, I could use that sensor to actually give you a sweeter cookie. Or I could actually, maybe if you didn't work out, I could give you more volume and less food. And they started thinking about a very different animal. And then they did another experiment, and they started collecting $10,000 a week for custom manufactured stuff, for packages and things like that. We did this quick, it was a 6-week experiment at Maya. and they ended up getting credit card swipes at $10,000 a week, the highest profit margins for Oreo. This is a $3 billion brand with 56 factories. So they started seeing that, and now there's a major initiative to have a $1 billion new line of revenue based on mass customization and direct-to-consumer. So I think there's business there, but I think you have to get in this mindset of simulate a year in a week, experiment rapidly, not just with the technology, but the business model and the cognitive psychology of the way people think, because there's all sorts of spaces to fill. And that's what I'm excited, I kind of said this is like an ecology. I think we should study nature. It's been around for on Earth, maybe 3 or 4 billion years, life has been around. Lots of experiments that we can see, and a rich, independent actors fill and use underused resources to fill economic places, right? That's life. Your waste is someone else's food. So I think there's a huge opportunity here, trillions of dollars of new opportunity. It's not obvious, though.
Yeah, got to work on it. Yeah. Awesome. Thank you so
Thanks,
much,
everybody.
Mickey.
Yeah,
really
thanks,
appreciate
Debbie.
it.